Let's take a look at geometric sequences in series. On the left side here, we have a sequence with common ratio of 3. And on the right side here, we have a geometric sequence with common ratio of 1 over 3. Terminology that you should keep in mind is that the left sequence here is divergent because it reaches towards infinity. And the right sequence is convergent because r is less than 1, the absolute value of r. Some important formulas that you should know is that u of n equals to u of 1 times r to the n minus 1, which represents the nth term of any geometric sequence. And if we look at this formula here, this represents the sum of the first n terms inside of a geometric sequence. Now, on the right side, we have s of infinity, which means the sum of all terms inside of a geometric sequence. And this only applies to convergent series, because if it's divergent, the sum to infinity is always just going to be plus minus infinity, so we don't care about that. But for convergent series, s infinity is actually going to be a finite number L, so that is only applicable for convergent series. So let's try out this problem here. Find the common ratio r of the geometric sequence with first term u of 1 equals to 2 and s of 3 equals to 14. So let's first visualize this. We have a sequence with 2, comma, u of 2, comma, u of 3, and so on and so on. And if we take this piece of information that the first 3 terms is equal to 14, it becomes 2 plus u of 2 plus u of 3, that is going to be equal to 14. Now, we know that u of 2 can be represented as u of 1 times r, and u of 3 can be represented as u of 1 times r squared. And we also know what u1 is equal to, which is 2. So we can also substitute that in, and we get 2 plus 2r plus 2r squared equals to 14. And I'm just going to move 14 to the other side here, and this would become 2r squared plus 2r minus 12. And I'm just going to divide by 2 because we want to get rid of that factor. It becomes r squared plus r minus 6 equals 0. Now, taking this, we can have a factor which is going to be r plus 3 times r minus 2. So therefore, r, which is the common ratio, is equal to -3 or 2. And that is the answer. So let's try out another problem here. Find the common ratio r and the general nth term u of n of a geometric sequence given u of 1 equals to 16 and u of 4 equals to 2. So right now, our goal is to find u of n. So u of n equals to u of 1 times r to the n minus 1. So it seems like we are given u of 1, which is 16, but we do not have r. So that is what we're going to try to find. So r is a question mark. Now, let's use u of 4 equals to 2. This becomes u of 1 times r cubed equals to 2, where u of 1 is equal to 16. And if you do r to the third equals to 1 over 8, r equals to 1 over 2 when you put a cube root on both sides. And therefore, we have what r is equal to. So we can say u of n equals, of course, u of 1 times r to the n minus 1. And if we substitute u of 1, because 16, and r is 1 over 2. So we get this general nth term formula. U of n equals this 16 times 1 over half to the n minus 1.